recording to the cloud? Uh-oh. What am I doing? Let me do that. Share, new share, Microsoft Word, share. All right, good. All right, so we're live. So when you look in your kits, there are a number of things in your kit as of note, and we'll take a little bit of time, not a lot, maybe 5 minutes, to go over some things. This is, of course, the Arduino Uno board. Oops. I knew I forgot something. There we go. Let me make this a little bit bigger. I need like a roving camera or helmet cam. All right, so this is the Arduino Uno Wi-Fi revision 2. Let me ground myself. And as we saw in this morning's module, we have for this the USB port right here, right? And this USB port will connect in to the data connection, but also get power for your computer. Now, this side, I'll call it the stubby side of the USB AB cable. Oh, Lordy, this is, brother. Let me try, something's gone awry with the, there we go. I apologize for this issue. All right. So you're going to plug in, after grounding yourself, the USB AB stubby side into the USB port for your Arduino. And then, what in the world? And then you're going to plug in the other part of your USB cable into your USB port. Now, some of you, if you have a laptop like mine, a Mac, it has USB-C connectors, and you can get all over the place, Best Buy, Amazon, other places, these translator cables that will convert from USB-C to USB 3.0. And so this is what it looks like, conversion cable. And so for some of you, if you have a Mac that doesn't have USB 3.0, 2.0, or AB, you're going to need a conversion cable. Question? Yes. Yes, absolutely. Let me go over some things. So for this task, because I want to walk you through the task, and then I'll spend a little bit of time talking about the parts. For this task, you're going to use your Arduino board, your USB cable, and a laptop or some machine, right? And so let's take about 5 minutes to talk about some of the stuff in the kit, right? And so in the kit, included in each kit, I have a CANA kit, which is a complete instance of a Raspberry Pi. And the thought was, you know, if there's somebody on your team who doesn't have the board yet, you can at least have one to use, right? And the CANA kit is complete. If you open it up, it has an HDMI cable, it has the power supply, it has a data cable, and it has a Raspberry Pi and a case. It also includes the SD card that you're going to use for the file system or hard drive for the Raspberry Pi. But we're not going to use the Raspberry Pi until sometime, I think after February, depending on curriculum and how things go, before the middle of the semester, when we talk about small board computers versus embedded controllers. We also, in this box, we have a 7-inch LCD display. And this is going to be the display for your Raspberry Pi, and it's a touch screen, right? And so if you chose to, you can implement a kiosk, but the Raspberry Pi uses HDMI and can display to an HDMI monitor, so you could plug it into an HDMI monitor if these are HDI in the room. But if you open this up, it has, remember, you ground yourself. And if you open this up, it has some driver software, and you want to be really careful with this because I only have one per kit. It has the LCD touchscreen with some mounting hardware that you can use. And the intent for this is to use it with the Raspberry Pi. This has a scratch on it, with the Raspberry Pi, right? So that if you didn't have a monitor per se for your Pi, you can at least use this to bootstrap it until we connect it to Wi-Fi and have you remote log into your Raspberry Pi. Because once you remote log in using the console, question. For the Pi or Arduino? I didn't include a USB AB cable for the Arduino. That didn't make the cut list for the first order. All right, so let's close that up. And then here we also have some wire strippers, right? And these wire strippers, we'll talk about a little bit later after electricity, is used to take the insulator off of wire. And we'll talk a little bit later about that. We also have a soldering iron set. And if you open that up, it's in a handy little case. And it includes soldering iron and some other tools that you will be using should we need to do some electrical work. And so in there are a couple of things of note. We have a wire cutter, right? And we'll talk about some lab protocol when we talk about safe procedures. Is really important when you're cutting wire. You know, for example, you hold the wire down and you point it away from other people when you cut the wire, because the wire can actually fly out those little pieces when you do the cutting, and you don't want to hit someone's eye, right? So there's some safety protocols that we have associated with this. We also, this green thing is a multimeter. It's used to measure current and voltage. And so we'll be probing some things to show you some diagnostic techniques. We also have here this blue handle thing. This is a soldering iron. And the soldering iron, you plug it in, it gets really hot, you use it to solder. And again, we're going to have some lab safety protocol stuff with this because this can burn you pretty badly, right? And so when someone joins my research lab, I go through a training procedure because it's really, really important to exercise good, safe practices, right? And so this kind of thing that looks like a pen, which has a coil inside of it, that coil is solder. And solder is a metal alloy, and you use it with the soldering iron to effectively melt the metal to create electrical connections between components, right? Of course, we have electrical tape. When you build a circuit, you don't want to have exposed bare metal if you're dealing with wires, right? And so once you solder wires together, you use your electrical tape to put this insulator, and we'll talk about insulators on Tuesday, over that bare metal wire. We also have inside of here, there's a black thing here, and this is a holder for your soldering iron. The soldering iron gets very hot, and when you're not actively using it, you put the soldering iron in here in the metal, and the metal can withstand the heat of the soldering iron, which is about 300 to 400 degrees Fahrenheit, and you let it sit there while you're using it, okay? And we'll talk about lab techniques another time, especially for things that have safety considerations associated with them. Then, of course, we have the wire cutters for cutting wire. We talked about that. We have some probes for the multimeter. And these probes have these little sharp ends, and that you use to very precisely touch one signal wire, another signal wire, and you'll actually see on the screen for the multimeter what voltage or current is on that conductor. Then we also have a number of little tips here, and these tips go on the end of your soldering iron. And depending on what you're soldering, you're going to put in a different tip when the soldering iron is cold, so that you can more effectively solder the type of component or wire or system you're trying to solder. And then lastly, also that I'll go over, or two things, we have the sponge, very cheap sponge. And the sponge, you'll wet this with water and you use it to clean off your soldering iron. Again, that's going to be part of lab protocol. You need a sponge. You want to keep the tip clean for your soldering iron because it's going to get kind of mucked up, and you want to make sure it's clean because clean soldering iron tips make for good solder connections. And of course, this is called a solder extractor. It's a vacuum. You push down the plunger, it cocks, and then you push the little green button and it pops up. When it pops up, a vacuum is created at this plastic tip. And so if you solder something onto your board or on a board and you find, oh, I didn't need to do that, and you want to remove it, you can use this. And again, as part of lab protocol, we'll talk about in another sitting. You can use this to heat up the solder with the soldering iron, and then you put this right on the solder joint, and then release the trigger, and it'll suck up the solder. Okay. All right. So that's roughly the kit, and it's pretty standard for soldering and doing some kind of hobbyist maker type of electronics. Please make sure that after you use something, you put it back, because it's very easy to lose parts, and we don't want to lose parts. So the next thing is this plastic bin. If you open that up, this has a number of assorted electronic components. Boy, that thing's strong. Okay. It has a number of assorted electronic components, and this tape is really, really pretty good. And if you open it up, well, you'll see, I'll just talk about it. You'll see some resistors, some capacitors, something called a breadboard, light emitting diodes. We'll talk about some of those on Tuesday. Various components that you need in companion with your board when you're trying to drive various components. And we'll talk about lab protocol and breadboards and stuff like that in another sitting. We also have this thing. This is called the ArdrewCam. It's a camera for the Raspberry Pi. And we're gonna also, time permitting, talk about computer vision types of things, not a lot, but using that sensory modality, which is quite interesting, with the Raspberry Pi. And so I wouldn't take it out of its container because we're not really going to use it, but it's an actual camera that is designed to use with the Raspberry Pi. Okay. So for example, if somebody wanted to detect if a person was in the room, then maybe, you trigger an actuator. Okay. So this one is an electronic kit, and this has other components in it. And has a breadboard, jumper wires, and some other components. Now, we have this one separate from the other one because there were things in here specifically that I wanted, right? Now, of course, if we had a longer amount of time to put the class together, then I would have actually shopped each component individually in some quantity, but we didn't have that kind of time. The big black box, or not big, the black box, that's a sensor kit. And inside of it, you'll see a card, and this card lists all of the sensors that are in the kit. And so you have things like moisture sensors, you have things like IR sensors. The PIR sensor is interesting because it detects human body heat, the presence of a living thing within some range of it. And so on this card has a description of all of the 48 sensors that are in the kit. And then there's a website associated with it that leads you through how to connect to the kit. And so that's where the digital I/O and the analog I/O will come into play, because some of these sensors output an analog signal and some of them output a digital signal, right? So we'll be looking at some classes of sensors, and we won't look over every sensor because, goodness, with 48 sensors, we could spend half a semester just looking at the sensors, right? And so we will talk about some of the sensors as a model for saying, this is how you interact with something that needs digital I/O. this is how you interact with something programmatically that uses analog I/O. But we won't go over every sensor. And in a future assignment, you'll have to go look at the documentation and say, yeah, this is an analog. I remember Holness said this is how you use analog and this is the API. Okay, so that's what I mean about when I said at the first class about assembling your own curriculum, because we don't have the time in the 15 weeks to go over every fine detail of everything. Okay, all right. And so some other things that we have a breadboard and some jumper wires. It's for prototyping circuits. And we'll talk about the electrical connection on the breadboard. And it's used for prototyping so you don't have to commit to soldering things when you're trying to test and develop something. It's once you're sure of your circuit that you actually start soldering on a PC board. But I think we might just leave it to breadboard for this class, for this first incarnation of the course. And then this isn't in your kit, but this is a solder vacuum. And if you're in a confined space soldering, you want to make sure when you're soldering that you are in a larger space with good ventilation. Now, the solder fumes won't kill you, but you don't want to be breathing them in, right? And so you want to be in a well-ventilated area, which this is. But if not, and this is what I use at home, you plug it in, it has a nice filter inside, and you put it over where you're working. And as you're working, this thing will suck the solder up, the solder fumes inside through a charcoal filter to clean the air. Now, the other thing that's in your kit looks kind of like this. And I've always called it a lobster. In the mid-Atlantic, you call it a crab, but you know, I grew up in Boston, so I'll call it a lobster. And this is a little workstation, and it has a magnifying glass and these two arms and these alligator clips or grippers, right? So it looks like a lobster, right? Except both claws are the same size. And when you're working with some things, I don't know about you, but you know, I need magnification because I can't really see those really tiny things very well. And so you'd use this, especially like if you're soldering or if you're working on a board, the two clips you clip to hold the thing you're trying to solder or you're working on, look under the magnifying glass. So it's an extra set of hands to help you hold things in place. And there are other types of models. I have one at home that has 4 arms and a magnetic plate that holds it up nicely. I might bring that in when I figure out how to film this stuff. But this is to help you, called helping hands for soldering. I call it a lobster because it looks like a, you know, like a lobster. Okay, any questions? And so I might augment all the kits with more cabling, with solder vacuums, putting together an order this weekend. I have to see what the budget is and what the running total is. Okay, any questions? No questions? All right, so there's all sorts of stuff that you can get, you know, but I've provided, I hope, all of the basics needed, particularly for the course. All right, so let me minimize this camera here, and let's look at some of the tasks for what I call BigMacAttack, because names are fun. And so for this, you'll be setting up your Arduino IDE environment and running your first sketch, developing your first sketch to run on your board. And so I'm just going to talk over it, but I want to spend majority of the time, we're here till 1:15, floating around the room. So this is going to be a short recording to help you get started. And so you're going to need a laptop that has a USB connection. If you're on a Mac and you don't have a translator, I have one you can borrow for now, but I need this back because some of the Macs have USB-C, and this translates between USB-C and the regular USB connection. And so what you're going to start out is also burn into your muscle memory. You ground yourself before you touch some electronics, right? And it should be kind of almost like a reflex because you wouldn't want static to kill your board. So first thing you're going to do, these are all our tasks, locate and install the IDE platform, Google search it, and it should be under arduino.cc, which is the primary source for all things, official source for all things Arduino. And then you're going to install the 2.0 release candidate. Now, the Arduino IDE has the 1.x version, which has been used for several years. And there's a new version, the 2.x version, which is out soon officially. The 2.0 version adds a lot of real nice bells and whistles. I think is worth your time to install the release candidate, which means it's very close to being the final version. Okay. Then you're going to navigate through the menu choices after you install it, and then go through the preferences to familiarize yourself with things like verbosity, how verbose it is in all the messages as it's compiling, linking, and staging. And then you're going to set your working directory, and then you're going to install the board manager because you're going to need that to be able to talk to the Wi-Fi revision 2 Arduino properly. And then you're going to look at the Wi-Fi Nina library for the Arduino Wi-Fi version 2, which is different from the Wi-Fi library for the Uno revision 3. So you want to make sure you're paying attention to that. And then you're going to incrementally develop some sketches. Now, I'm going to run my Arduino IDE. I've already installed it. And I'm going to leave up on the screen the sketch for doing what's called the Blink demo, as well as getting the MAC address. Now, there's some other stuff I have in there. Let me mute. Oh, that's the wrong one. My Wi-Fi password is up there. Let me get rid of that. File save. I'm going to edit that out of the video too. All right, let me unmute the screen. Did that really? Okay. So I'm going to leave this up and float around the room and kill the audio. Let me get rid of the serial monitor. Let me make this bigger. No, that won't let me make it bigger. How are we going to do this? Yeah. Well, how about I'll just do the setup and the, oh, I wasn't planning on this. See, preferences, let me make the font smaller. Let me make that 8 point's gonna be harder to see though. Let me see if that's a little bit better. All right, we'll just have to deal with it. All right, so why don't we, what I'll do is, let me just